Hi, good morning everyone. Myself K.Nanthagopal. I'm working as Assistant Professor in School of Mechanical Engineering, VIT University, Vellore. My lecture topic is combustion in SI and CI engine. So first I will give the information or my first level of information about the combustion, the normal combustion in SI and CI engine. Then I'll move to the abnormal combustion in both IC engines, in both SI and CI engine. Combustion in SI. First, we can discuss about the combustion in SI engines. Combustion, basically, combustion is a rapid chemical combination of hydrogen and carbon in the fuel with oxygen, resulting liberation of energy in the form of heat. Basically, the chemical reactions. The hydrocarbon fuels contains a certain amount of hydrogen and carbon. These two, hydrogen and carbon, react with the oxygen, and during the chemical reaction, a huge amount of heat will be released. That process is called as a combustion process. So combustion of air fuel mixture is mainly depends upon the chain reactions, because the combustion will be initiated at what particular point by the spark plug or through diesel injection. After that, due to the chain reactions, this flame will be spread out to the next part nearby area, and again some other certain conditions are required for complete combustion process in SI engine. The first important condition is there must be presence of combustible air fuel mixture. For whatever the air fuel mixture is available in the cylinder, those air fuel mixture must be in a within a combustible range, within the ignition limit, and that slide shows the ignition limit for all the hydrocarbon fuels. And when the supplied air fuel mixture is between 7:1 to 30:1, then the combustion process can be completed, or it can be complete process. When the supplied air fuel mixture is beyond this limit, like less than 7:1, like 6:1, or more than 30:1, then there is a possibility of flame misfire sort of process. And second required condition is some means of initiating the combustion process. And the hydrocarbon fuel, especially the gasoline, have very high self ignition temperatures, more than 350 degrees Celsius. So whatever the conditions are available at the end of the compressor stroke, that conditions are not enough to ignite the combustion process. That's why some kind of external source is required to initiate the combustion process. That's why most of the petrol engines are equipped with some kind of ignition system. It may be battery ignition system or electronic ignition system, something like that. And third one is there is a need of stabilization and propagation of flame in the combustion chamber. Once a flame is produced by the spark plug inside the cylinder, then the flame must be in a stabilized form, and it has to propagate towards the cylinder wall. If there is no flame stabilization or flame propagations, then there is a possibility of flame misfire, the misfiring process. Whatever the flame is generated from the spark plug, the flame will misfire within the place itself. So these three conditions are very important for achieving the complete combustion in SI engine, spark ignition engine. And next topic is stages of combustion in SI engine. And this combustion process, even though it's a chemical reactions, it can be divided into three different stages, and that can be formulated from the pressure crank angle diagram. The first one is the theoretical pressure crank angle diagram, whereas the second one is the actual pressure crank angle diagram. If you look at the first theoretical pressure crank angle diagram, during the compression stroke, the cylinder pressure is increased up to the top dead center. After that, it is assumed that heat addition will take place at constant volume conditions. So there's a pressure rise during heat addition process. After that, during expansion process, the cylinder pressure will decrease. This is the theoretical pressure crank angle diagram. The second one is the actual pressure crank angle diagram. Can be taken with the help of the pressure sensor or pressure transducer along with the data system, and to measure the cylinder pressure with respect to crank angle. Well, the actual crank angle diagram shows that in petrol engine, the maximum cylinder pressure can reach up to 30 to 40 bar or 50 bar. It also depends upon the compression ratio. And so in x-axis, they given the crank angle, especially during the compression process, it may happen around 30 to 40, 60 to 80 degree before TDC during compressed stroke, and it may happen it may end after 30, 80 to 60 to 80 degree after TDC. And here the combustion process can be divided into three stages with the help of three important points. The first one is point A is a spark ignition. The spark is ignited just before TDC at the end of the compressed stroke, and here in this diagram the spark is ignited around 18-20 degree before TDC. Again, we have to remember that this spark timing or spark ignition also depends upon the engine speed and load. Whenever the engine speed is increased or decreased, or engine load is increased or decreased, and the spark timing should be adjusted based on the engine speed and load. And the engine load is nothing but the position of the throttle valve. Based on the position of the throttle valve, the spark time should be adjusted. This is the point A. Second one is point B. Point B is the initiation of the combustion process. Once the spark is ignited around 15 degree before 20 degree before TDC, but the combustion process initiated around 8 degree before TDC, and it's clearly indicate that once a combustion won't be take place immediately, it will take some time. And so the point B is can be identified for the deviation of the motoring curve from the normal curve. So motoring curve or non-firing curve means if once the spark is ignited, if there is no flame development, then the cylinder pressure will decrease, deviate in this direction. This is called as a motoring curve or non-firing curve. The deviation of motoring curve or non-firing curve from the normal curve is the location of point B. Third one is point C. So point C is a maximum cylinder pressure development, and in this diagram the maximum cylinder pressure is developed around 10 degree after TDC. If you look at the theoretical pressure triangle diagram and after pressure triangle diagram, so in the theoretical pressure triangle diagram, the maximum, it is identified that the maximum cylinder pressure reached or developed exactly at top dead center. But in actual case, the maximum cylinder pressure is developed are only at 5 to 10 degree after TDC. It is very difficult to create maximum cylinder pressure at top dead center. It is due to the variation of engine speed and load and some other parameters. And this is the point C. Based on these 3 points, we can divide the stage combustion process into 3 different stages. The first stage is called as the ignition lag period or early flame development. It is the time duration between point A and B, A to B. It is the time duration between spark ignition and starting of the combustion process. Second stage is the flame propagation. It is a time duration between point B to C. At what point the combustion process is initiated up to the maximum cylinder pressure development. Third stage, it is the after burning. This third stage will start from point C around 10 degree after TDC during expansion stroke. And so the first stage is the ignition lag period, or it can be called as a early flame development. It is the first stage in all kind of IC engine. Whatever may be the fuel, it may be the petrol or diesel or CNG or LPG. The first stage of the combustion process in all kind of hydrocarbon IC engine fuel is called as the ignition lag or early flame development. It clearly indicates that once a spark or diesel is injected in whatever in both IC engines, the combustion process will take place immediately. It will take some time. This duration is called as a ignition lag period. And if you look at the total combustion duration, it's around 30 to 90 degree of crank angle duration. So the first stage, the ignition lag period or preparation phase, during this period, the growth and development of a semi-propagating nucleus of flame is taking place. Once a spark is ignited, it will produce just like a dot. From this spark, the growth and development, the nucleus of the flame has to develop. That's happening during this ignition lag period. That's why this stage is called as a preparation phase or early flame development. And in terms of crank angle, the ignition length period is around 10 to 20 degree. In terms of seconds, it's around 0.015 seconds. This ignition lag period depends upon number of parameters. Here I listed out some important parameters. The first one is the nature of the fuel. The ignition lag period for the particular engine is mainly depends upon the nature of the fuel. Nature of the fuel means what is the ignition temperature. The fuel is having very high ignition temperature. Those fuel might have very long ignition lag period. The separate fuel is having short self flame temperature, low flame temperature. Then those fuel may have very short ignition lag period. So the important property is the auto ignition temperature of the supplied fuel. Second one is mixture ratio. It's nothing but air fuel mixture. This slide shows the effect of mixture strength on ignition lag period and in milliseconds. It's clearly indicate that when the supplied air fuel mixture is 10 to 20 percentage close to stoichiometry, then those fuel might have short ignition lag period. If the supplied air fuel mixture is beyond this limit, then it may increase the ignition lag period. Third parameter is initial temperature and pressure of the incoming charge. And the temperature pressure of the incoming charge also affect the ignition lag period. So especially during summer and summer season, when the atmospheric temperature goes to more than 40 degrees Celsius, during those conditions the ignition lag period might be very less. It is due to the increase in atmospheric temperature. The pressure may not be so much different because the IC engine may be the natural aspiration or turbocharger. The pressure may not have the atmospheric pressure not have that much variation, but the temperature plays a major role. The fourth parameter is compressor ratio. So compressor ratio is the design parameter of IC engine, and if you increase the compressor ratio, then that higher compressor ratio might reduce the ignition lag period. So if you reduce the compressor ratio for petrol engine, it may increase the ignition lag period. Then next parameter is the proportion of the exhaust gas. So how much amount of residual gas is present during combustion process, or that's also one of the major parameter. The proportion of the exhaust gas also considered as a one parameter. If you increase the exhaust gas quantity inside the cylinder, then it may dilute the fresh air fuel mixture. It can be increase the ignition lag period. Then last parameter is electrode gap. The gap which is available in the spark plug also could be the major factor in ignition lag period. The second stage is called as the flame propagations or propagation of flame. Once the flame is generated the spark plug, now this flame will move towards the cylinder wall, and it is called as the flame propagations. And this flame propagation is depends upon the number of parameters. The flame velocity influences the rate of pressurized in cylinder. What is the velocity of speed that directly influences the pressure development in the cylinder? And this flame will reach towards the cylinder wall, and it is due to the two parameters. One is due to the heat transfer between burned molecules to the unburned molecules. So when the flame is generated, and there must be heat transfer from the burned molecule, from burned mixture to the unburned mixture. If there is no heat transfer, there is no possibility of flame propagation inside the cylinder. Another factor is due to the diffusion of burning fuel molecules from the combustion zone to the adjacent layer of the unburned mixture. When the this heat transfer is happened due to the diffusion of the burning fuel molecules from the combustion zone to the adjacent nearby area. Due to these reasons, the flame velocity increases during the second stage. And again, this heat transfer and diffusion happen due to the pressure difference between the burned gases and the unburned gases. Third stage of the combustion process is the afterburning, and This stage will start from the point C during expansion stroke. By the time pistons move from TDC to BDC during expansion stroke, so it will increase the cylinder volume. By the time only 5% of the unburned mixture is left out in the cylinder, and it won't increase the pressure. The heat transfer during the third stage is very less. That's why it's called as a last stage or after burning. During the stage, the flame velocity is very low and there is no pressure rise. And this is what about the stage of the combustion process. Second topic is the combustion in CI engines. The combustion process in CI engine is entirely different from the SI engines, and because in a petrol engine, during suction stroke, the air and the fuel mixture is mixed and it is supplied inside the cylinder. Then it is compressed. After that, the compressed air fuel mixture is ignited by the spark plug, then it will generate the flame. But in diesel engine, during suction stroke, only the air is supplied. After that, the air is compressed. At the end of the compressed the diesel is injected at very high pressure. In conventional diesel engine, injection system diesel engine, the injection pressure will be around 200 to 300 bar, whereas in CRD system, which is used in most of the diesel vehicle nowadays, maybe around 1500 to 2000 bar. Look at the injection pressure, whereas in petrol engine, the injection pressure is very low. In MPFA system, it may be 2 to 6 bar. In GDI system, it may be around 100 to 150 bar. In carburetor system, it may be less than atmospheric pressure. So the injection pressure plays a major role in diesel engine. And here, this slide shows the spray pattern of the diesel injection. Depends on the number of spools, the diesel will be injected inside the cylinder at particular directions at high pressure, and once the diesel is injected, it has to mix with the available compressed air. For this purpose, there is a need of air movement inside the cylinder. Whatever the air is available in the cylinder, this air, it has to move or it has to forward with respect to diesel injection, fuel injection. If there is no air movement in this cylinder, then there is no possibility of mixing of fuel particles with air. The fuel particles cannot be mixed with the available air. That's why the air might be in a proper movement in the cylinder at the time of diesel injection. Otherwise, there is a possibility of flame misfire inside the cylinder. This is what about the flame misfiring process. There is no combustion. The combustion process will be generated. It's because of the improper mixing. The fuel particles not mixed properly with the available air. And this is the stages of combustion in CI engines. So this is the actual pressure triangle diagram. And here the maximum in diesel engine, due to the higher compressor ratio, the cylinder pressure can go up to 990 to 100 bar, whereas in petrol engine it may be around 40 to 50 bar. It's because of the variation in compressor ratio. And in diesel engine, the combustion process is divided into 4 different stages. The first stage, it's between point 1 to 2. Second one is 2 to 3. Third one is 3 to 4, and fourth one is after 4. And the first one is, and we can locate this point 4, 1, 2, 3 based on 3 different conditions. First one is starting of the diesel injection. So in diesel, in this diagram, the diesel engine starts around 18 to 20 degree before TDC. The diesel is injected at very high pressure. So once the diesel is injected, it's a point A. And point B is the starting of the combustion process. It's a deviation of motoring curve or non-firing curve from the normal curve. It's a point B. Third one is point C. It's a maximum cylinder pressure development inside the cylinder when we close to top dead center around 2 or 5 degree after TDC. Third one is point D, is the end of diesel injection. So in this slide, it clearly shows that diesel injection starts around 20 degree before TDC, and the diesel engine will be completed around 10 degree after TDC. The total duration diesel engine is around 20 to 30 degree of crank angle duration. And first stage, it's a delay period, ignition delay period, And in diesel engine, the delay period is the time duration between starting of the fuel injection and starting of the combustion process. And this delay period again in this divided into two format. One is physical delay and second one is chemical delay period. The first stage of the ignition delay period is the physical delay period. It is a time duration between the beginning of the injection and attainment of the chemical reaction conditions. Once the diesel engine starts, combustion process won't be taking immediately. It will take some time, and this duration is called as a physical delay period. And here in diesel engine, this physical delay period includes the fuel spray atomizations, evaporation of fuel particles, and mixing of the fuel vapor with the cylinder air. All this process has to take place. Everything is happening during the physical delay period. And the good atomization is required very high fuel injection pressure, small injector hole diameter, and optimum fuel viscosity and high. These are the parameters. So these are the parameters directly affect the physical delay period. So the fuel must be injected at very high pressure, and the fuel nozzle diameter must be very smaller one, and fuel viscosity must be low, and the available cylinder pressure, the compressed air cylinder pressure must be very high. And the rate of evaporation of fuel droplets depends upon the droplet diameter, velocity, and fuel quality, pressure, and temperature of the incoming air. Second stage is the chemical delay period, and once the conditions are available for chemical reactions, the pre-flame reaction starts slowly, then it accelerates until the ignition takes place. This is called as a chemical delay period. Generally, the chemical delay period is longer than physical delay period in diesel engine. At higher temperature, the physical delay period may be longer than chemical delay period. And if you compare the ignition lag period of SA engine, it's almost equivalent to the chemical delay period in diesel engine. The reason is, so whatever the process happening during the ignition lag period in SA engine, the same process happening during the chemical delay period in diesel engine. So the delay period affects the rate of pressurized, also the startability. It's the first stage. Second stage is called as the pre-mixed combustion phase. It is a duration between 0.1 to 2. It's a duration between starting of the combustion process and starting of the maximum up to the maximum cylinder pressure development. It is called as in diesel it's called as a pre-mixed combustion phase. So here higher temperature pressure during the delay period occurs rapidly in a few crank angle durations. It's the second stage. And the third stage is the mixed controlled combustion phase. So after the premix gas consumed, the burning rate is controlled by the rate at which the mixture becomes available for burning. Once the premix gas is consumed enough rate, so the rate of burning of the fuel particle is depends upon the how much amount of fuel particles available for the burning or chemical reactions. The burning rate is controlled primarily by the fuel air mixing process. And it's the third stage. It's happening between point C to D, from the maximum cylinder pressure to the end of diesel injection. Then last one is late combustion stage. It will start from point D. Once the diesel injection is completed, now certain amount of fuel particle is left out in the cylinder. When this fuel particle is burned during the expansion stroke, it won't increase the pressure, it will decrease the pressure only. So it's called as a late burning or late combustion phase. The heat release may be proceed at lower rate well into the expansion stroke. So no addition of fuel is injected during this phase. So combustion of any unburned liquid fuel and soot is responsible for this late combustion phase. So these are the four stages of the combustion process in diesel engine. And this two called as a normal combustion process. And sometimes the combustion process may be in abnormal state. Those kind of combustion process called as the abnormal combustion process in SI and CA engines. So normal combustion occurs with the common flame propagations inside a cylinder and smoothly varying the cylinder pressure. The cylinder pressure will be a normal one. So abnormal combustion process occurs with slightly or high pressure fluctuations during combustion process. And this abnormal combustion process may happen due to two reasons. One is called as a detonation or knocking in IC engine. Second one is called as a pre-ignitions. So pre-ignition means ignition by the hot deposit, not by the spark plug or diesel injection. And so the knocking is the term is used to describe the clinking noise emitted from a SI engine undergoing the abnormal combustion process. The noise is generally shock waves produced in the cylinder when unburned gas auto-ignite. See, there is knocking inside the cylinder that can be identified by providing the knock sensor into the cylinder, so that the driver, those knocking process can be displayed in the dashboard, so that the driver can do the rectification immediately. First, we can discuss about knocking in SI engine. And knocking in SI engine is the abnormal combustion phenomenon which occurs when the auto ignition of a portion of N gas take place get of advancing the flame. Look at this figure 1. So knocking is due to the auto ignition of the portion of N gas get of advance in the flame. Once the flame is generated from spark plug, this flame travels towards the cylinder wall. It moves towards the cylinder wall. And by the time, if there is a possibility of auto ignition of the N gas or unburned mixture close to the cylinder wall, then this flame may create it may create one more flame. This flame may move in the opposite direction. So now there is a main flame from the spark plug, then additional flame from the N gas. So when these two flames are collide each other, it will create enormous amount of pressure. This pressure development is called as a knock-in or detonation in SI engine. So in SI engine, the abnormal combustion or knock detonation is due to the auto ignition of a portion of N gas. Auto ignition of a portion of N gas close to the cylinder wall. And if there is a knocking process, a detonation process in the cylinder, then the pressure waves should be generated. So that can be identified or sensed by the locating the pressure sensor inside the cylinder. Look at this slide. So the first one, spark occurs by the spark plug and combustion process begins, and it will generate the flame. The flame continues rapidly and it's complete. There is no auto ignition of the N gas. This is a normal combustion process. And look at the second one. The spark is not ignited. By the time at the end of the compressor, the available air fuel mixture is ignited by the hot deposit. It may be the carbon particles or it may be some other source. And when this source act as ignition source, and it will create the flame just close to the cylinder wall. And now there is a regular ignition by the spark. Now, so when this ignite the remaining fuel, the flame, there is a two flames collide each other. It is called as a pre-ignition in SI engine. So pre-ignition in SI engine is the ignition due to the hot deposit or due to the overheat in the spark plug or exhaust valve. And to look at the third diagram, spark occurs by the spark plug, combustion process begins. There is a continuous. By the time there is an auto ignition of the N gas close to the cylinder wall. It is located it's happening exactly opposite to the spark plug. And this process is called as a detonation. So detonation is also one of the abnormal combustion process. It is happening to the auto ignition of the N gas unburned mixture. Here also there is a flame collisions. In pre-ignition means ignition by the hot deposit inside the cylinder. The reason for detonation in SI engine, the first reason is when there is too much compressions. The too much compression is due to the accumulation of the carbon deposit inside the cylinder. If the engine is not serviced properly, it will increase the carbon deposit. The carbon deposit will accumulate at the top of the cylinder combustion chamber, so that it will reduce the clearance volume. When the clearance volume is reduced, it will increase the compressor ratio. When there is too much compression, it may act as a source for detonation process. Then second one is over advanced spark timing. When the spark timing is advanced during compressor stroke, it will create too much pressure rise. Third parameter is when the engine is overheated. The overheated engine may take place due to the low coolant circulations, or when the thermostat is very hot, or when the water pump is not functioning properly. So due to these three reasons, there's a possibility of engine overheating process. So when the engine is overheated, so the detonation may take place. Fourth, next parameter is overheated air during hot weather. Even the atmospheric temperature plays a major role for detonation process in SI engine. The overheated air during hot weather during summer season, so detonation process may happen, might occur in SI engine. Then spark plug is too hot. When the spark plug is very hot, and that spark plug act as a source, ignition source during compression stroke. So it may create pre-ignitions, or it may create the auto ignition, or so pre-ignition into the cylinder. Or when we use low octane rating fuel, the typical octane rating of petrol fuel is around 80 to 90. If you use any kind of low octane rated fuel, it may create knocking in SI engine. The effects of detonations. The first problem is noise and roughness operations during detonation process. So the engine may run in a very huge amount of noise may be generated, and there is a possibility of damage of the components also. Some of the components may be severely damaged, and it will increase the heat transfer. More amount of heat will be transferred to the cooling medium and the exhaust gas, and if there is a high heat transfer rate, it will reduce the thermal efficiency. Then, so when the engine is running under the knocking conditions, it may create the pre-ignition also. The last one is decrease in power output. The power output of the engine will be reduced. And to avoid these difficulties in the detonation process, we have to consider some of the design parameters. The first one is use of low compressor ratio fuel, compressor ratio. The SI engine must be designed with a lower compressor ratio. That's why the typical compressor ratio of the petrol SI engine is around 8 to 12. Then increase in turbulence. So turbulence might be huge amount of turbulence might be generated during combustion process. Then third parameter is suitable combustion chamber design. The combustion chamber must be designed with a proper size and shape, because the flame travel distance is fully depends upon the design of the combustion chamber. Then last parameter is location of the spark plug, or use of two or more spark plug. In some of the engine they are using more than one spark plug, so the location spark plug plays a major role in SI engine. And these are some of the typical combustion chambers used nowadays in petrol engine. The first one is wedge chamber, and hemispherical head, and bowling piston type, and bathtub head combustion chamber. The last one is pentroof design. Look at this one. In all the cases, the combustion chamber is a very compact shape and small in size, because in all the things the flame travel, the spark plug located at one point in wedge shape, and every design combustion chamber design is fully focused upon the flame travel distance. So how much amount of time is required to reach the cylinder wall from the location spark plug. So these are the damages due to the abnormal combustion process. Due to the very high pressure inside the cylinder, so sometimes the connecting rod be broken, or the piston in cylinder might be jammed. So when the connecting rod might be hit the cylinder block, so anything happened during abnormal combustion process. And these are the parameters, the design parameter of IC engine. How we can control the detonation process: the compressor ratio, throttle, spark timing, inlet air temperature, inlet pressure, so cylinder combustion temperature, wall temperature, the cylinder and combustion chamber wall temperature, coolant temperature, airfill ratio, turbulence, engine speed, and distance of flame travel. A major effect on unburned charge, whether it's affecting temperature, density, action to be taken to reduce the detonation. Look at this one. For a compressor ratio must be lower for petrol engine to avoid for the knocking difficulties, and throttle, the position of the throttle valve. And if there's a knocking inside the cylinder, the first thing is the position of throttle valve should be reduced, so that it will minimize, control the available airfill mixture in the cylinder. So we can temporarily avoid from the knocking difficulty. Spark timing should be retarded. The spark timing should be take place close to the top dead center during knocking conditions. Inlet air temperature and inlet pressure. These two parameters must be ready. That's why most of the petrol engines are not equipped with the turbocharger or supercharger concept. Those things will increase the inlet pressure and temperature. So cylinder temperature must be reduced, and coolant temperature also reduce, and airfill ratio make very rich or weak. If there is a detonation in cylinder, the separate airfill mixture in cylinder must be very very rich or very lean. Turbulence must be increased. Engine speed should increase, because the turbulence is directly depends upon the engine speed. If you increase the engine speed, automatically the turbulence will be increased in the cylinder, and the distance the flame travel, this must be reduced. Then next topic is SI engine fuel rating, and all the SI engine fuels are rated by important number. It's called as the octane number. So octane number determines the whether or not the fuel will knock for a specified engine at a specified operating condition. Generally, octane number is a mixture of iso-octane and normal octane. The typical octane number of iso-octane is 100, and typical octane number of normal octane is 0. And the available here having how much amount of iso-octane and normal heptane by volume is called as a octane number of any specified fuel. And other rating of SI engine fuel is performance number. It's a ratio of knock limited indicated mean rate of pressure of the tested fuel by knock limited indicated mean rate of pressure of the iso-octane. Third one is highest useful compressor ratio. It's a maximum possible compressor ratio that the SI engine can run without knocking difficulties. It's called the highest useful compressor ratio. These are the typical condition of the conditions for octane number measurement. So two kind of octane numbers are used generally. One is research octane number and motor octane number. These are the specific conditions. These are the typical octane number of most of the fuels used in petrol engine. So methane, so CNG, LPG, so methanol, ethanol, then iso-octane, then regular gasoline. The typical research octane number of regular gasoline is around 91. For motor octane number is 83. And if you want to increase the octane number of any kind of petrol, then so some of the commercial additives are commercially available. Sometimes back people were using yeast based compounds like tetraethylate and tetramethylate in last century, but nowadays these two are completely prohibited one. Now people are using ethanol based compounds or ether based compounds, methyl dentate butyl ether or ethyl dentate butyl ether. So it's formed by reaction of reacting methanol with isobutylene. Next topic is knocking diesel engine. So knocking diesel engine is due to the delay period only. If there is a long delay period, then there is a huge amount of fuel may be accumulated inside the cylinder, inside the combustion chamber. When all these fuels burn simultaneously, it will increase the pressure. This large amount of fuel may cause high rate of pressure rise inside the cylinder. Look at the first one and look at the duration between starting of the injection and starting the combustion process. Just for example, if the delay period is around 5 seconds, within 5 seconds around 5 grams of diesel particle is injected. When this 5 grams of diesel particle is burned simultaneously during the delay, after the delay period, then it may create little bit amount of pressure. It's a normal combustion process. If you increase the delay period around 10 seconds, then the accumulation of diesel particles around, it may be around 10 grams. When all the 10 grams of diesel is burned simultaneously, then it will increase the enormous amount of pressure. This process is called as a knocking in diesel engine. Now we can compare the knocking process both in SI and CI engine. So knocking in SI engine is due to the auto ignition of N gas away from the spark plug. It's near end of the combustion chamber. Whereas in diesel engine, knocking is due to the auto ignition charge at the starting of the combustion process. Look at these two slides. So in SI engine, knocking is taking place at the starting of the combustion process. The pressure waves generated during starting of the combustion process. Whereas in petrol engine, knocking is taking place at the end of the combustion process. So first difference. Second one is knocking intensity. So knocking intensity is very high in petrol engine, and whereas in diesel engine it's somewhat low. And third one is pre-ignition process. If there is any possibility of pre-ignition in diesel engine? No, because the diesel is injected only at the end of the compressed stroke. There is no possibility of pre-ignition during compressed stroke in diesel engine. And fourth last difference is judgment. How we can identify the knocking in SI and C engine. In SI engine, it is relatively easy to distinguish between the knocking and non-knocking operations. But in diesel engine, it is very difficult to identify the knocking process and abnormal combustion process, knocking process, normal combustion process, because the normal combustion process it's happening due to the auto ignition of the diesel particles. So we cannot identify whether the engine is running under the knocking conditions or under the normal conditions. These are the types of combustion. Some of the types of combustion are used in diesel engine. The first one is called the thoracic combustion chamber. It's an open type combustion chamber. The second one is the pre-combustion chamber. It's an indirect injection diesel engine. So factors to produce a knocking in SIAC engine. So here I listed some more important factors. The self-ignition temperature might should be low, high for diesel engine, and for petrol engine it must be high. Delay period for SA engine there must be a long. There is a need of long delay period. For diesel engine the delay period should be very short. Compressor ratio of SA engine must be low. For diesel engine compressor ratio can be increased. That's why the typical compressor ratio, thermal efficiency of the diesel engine is higher than petrol engine. Then inlet temperature and pressure. The inlet temperature pressure must be low for petrol engine. For diesel engine it should be high. Then speed. The SA engine must be designed with the higher speed, whereas for diesel engine should be designed for the lower speed. Cylinder watt temperature should be low for petrol engine to avoid knocking difficulties. For diesel engine should be higher. The cylinder size, the combustion chamber valve, the cylinder size must be a smaller one for petrol engine. For diesel engine there is no limitation. We can use the larger cylinder diameter. And all the cetane diesel fuels are rated by cetane number. Cetane number is the ability to auto ignite. How fast the fuel will auto ignite is a clear indication of the cetane number. So cetane number can be identified two fuel. One is the isocetane, and its chemical formula is C16H34, and normal cetane. And cetane number is a mixture of percentage of normal cetane plus 15 percentage of 15.15 into percentage of isocetane. And so the typical cetane number of diesel fuel is around 40 to 60. These are the conditions are used to measure the cetane number. The help of the variable compressor ratio diesel engine. And so for the low cetane rating fuel, delay period is long, and most of the fuel is injected for auto ignition and rapid combustion. Under the extreme cases, அவங்க மேல இருக்காங்க. ஆமா இந்த ஒரே விஷயம். சரி. For high cetane fuels, delay period is short, so very little fuel is injected before auto ignition. Heat release rate is controlled by the rate of diesel injection and fuel air mixings. This is what about the impact of cetane number in knocking process. So thank you for your patient listening. If you have any queries, you can ask.